All right, lesson 7.3 is about factoring trinomials when a equals 1. And I'll explain what that means in just a second here. First, to go over some key terms. Trinomial, remember, is a polynomial with 3 terms. The tri, T-R-I, means 3, like a tricycle. It's kind of a prefix there. It will always mean 3. A quadratic is a kind of polynomial whose degree is 2, so it has like an x squared or a t squared, some variable squared would make it a quadratic. So when it's a quadratic trinomial, it's specifically a trinomial, has 3 terms, and it has an x squared term or some variable squared term. So it would look like this, the ax squared plus bx plus c. Now today, when we're looking at factoring things, we're only going to be worried about the ones where a is 1. So this coefficient out front here, this a, is always going to be 1 in each of our trinomials, our quadratic trinomials that we are trying to factor. So before we go on to factoring those, I want to review some expanding pieces. So if we need to expand, or remember that means like multiplying, we have 2 different binomials. X plus 5 is being multiplied by x plus 3. When these binomials are written right next to each other and there's no add or subtract in between there, that means we're multiplying these 2 pieces. So remember how to expand this or to multiply them. That's where we use our foiling. We distribute each piece, x times x, x times 3, and we do 5 times x and 5 times 3. So when we look at that, x times x is going to be x squared. X times 3 is plus 3x. They're both positive, so it's plus 3x. Positive 5, positive x becomes positive 5x. Positive 5 times positive 3 becomes positive 15. Okay, so this was our first step. We multiply each piece. Now we need to look at that and say, all right, where can we combine any like terms? Here we have positive 3x and positive 5x. So we can combine those. This one is a constant. It won't combine with anything. This is an x squared term or a quadratic term, so that's not going to combine. So the only ones we combine are 3x and 5x. That's going to make 8x. So again, what I kind of want you to notice about this is we can go from this piece in blue, this x squared plus 8x plus 15. We can kind of work our way backwards then. Here we worked our way forwards. We went this way. We took our 2 binomials and multiplied them out and got to x squared plus 8x plus 15. Well, today we're going to learn about going the other way. We're going to take this trinomial and learn how to work backwards and putting it into these 2 binomials. So let's see what that looks like. Again, we're only concerned with our trinomials that are quadratic, so they have an x squared term like this, and they have to be in this form, ax squared plus bx plus c. So let's look at our trinomial here. What is our a value? So it's what number is out in front of x squared. So this one has a hidden coefficient of 1, so our a is 1. This one, again, has kind of a hidden coefficient right here of 1. So our b value, because we want plus b, our b value is actually negative 1. So we have a minus in front of it. And our c value is what is the last piece here. What are we adding at the end? We're adding a negative 6 or a minus 6 there. So we have a is 1, b is negative 1, c is negative 6. And in this case, yes, our a is 1, so this is one of our quadratic trinomials that we will be working with. Now, whenever we have a quadratic trinomial like this, with our a equaling 1 out front, we ask ourselves, okay, what 2 numbers will multiply to c, this negative 6, that will add up to negative 1, this b value? We need 2 numbers that will add to this that multiply to this. And how come that works is here we need 2 numbers that will multiply to 15 that add up to 8. In this case, we had 3 and 5. 3 and 5 add to 8 right here, and they multiply to 15 right here. So that's where we got this 5 and the 3 from. So same thing, we need to know what 2 numbers will multiply to make negative 6 that will add to negative 1. Because this is negative, we're going to have at least one negative. One is a negative and one is a positive. Because this one is negative, our negative number is going to be bigger. So the only way for that to work is if we have negative 3 times positive 2. Negative 3 times positive 2 is going to be negative 6. Negative 3 plus positive 2 will become negative 1. So these are going to be our two different numbers that we're looking at. So as we take that away as our factors, we'd have x minus 3, that's this negative, and x plus 2, that's this positive. And in fact, I'm going to write in the positive there so that we remember that. Negative 3 and positive 2. Now, I'm not going to do this for every single one, but on this one, I'm going to double check here. We're going to FOIL this really quick to make sure it works. Okay, so when we do this x to each piece, we get x squared. X times positive 2 is plus 2x. Now I have to do this next piece. Negative 3 times x and negative 3 times positive 2. Negative 3 times x is minus 3x. Negative 3 times positive 2 is negative 6. Combine any like terms. We have a positive 2x and a negative 3x. This quadratic piece stays on its own. This constant stays on its own. So we have x squared. These two combine to make negative 1x. This one stays alone to make negative 6. And this is exactly the same as what we started with. So in the end, we found out for sure this right here, get rid of that, these two factors, these two binomials, the x minus 3 and the x plus 2, those are our two factors then. These two multiplied together will make this trinomial. Let's try it with another one. We've got another trinomial with ax squared plus bx plus c. Our a, in this case, it's what number is out in front here, is 1. So this one is going to work for us. Our b value this time is 10. And our c back here is 24. So again, we're asking ourselves, what two numbers will multiply to 24 that will add up to 10? So you might be tempted to think, okay, we've got like 2 and 12. Because 2 times 12 is 24, and 12 minus 2 would be 10. But we don't want to subtract them, because this is positive and this is positive. We want them both to add up to this number. So this would actually become 14. So these ones aren't going to work. We need to think what two numbers multiply to 24 and add up to 10. The only ones that will work would be 4 and 6. And both of these are positive. Because 4 times 6 is 24. 4 plus 6 is 10. So those are going to be our two factors there, x plus 4 and x plus 6. If we were to check this, if we were to FOIL this out, this product, these two multiplied, would become this trinomial. See example 4. Again, we have our trinomial, ax squared plus bx plus c. The a out front here is 1. The b is going to be positive 12. The c is going to be negative 35. So the question, again, that we have to ask ourselves is what two numbers will multiply to negative 35 and will add to positive 12? Now again, we might be tempted to think, okay, 35, we can use 5 and 7, because 5 times 7 is 35, and 5 plus 7 is 12. But remember, this is a negative 35. So one of these two numbers would have to be negative. If we did negative 5, then these would add up to positive 2. So we don't want that one. If we did this one to be negative 7, then again this would add up to a negative 2. Neither of those would add up to 12. So no numbers here will actually work. There are no two numbers that will multiply to negative 35 that add to 12, which means we can't actually factor this one. So we would say we cannot factor it, or you can say it's prime. This is the smallest or the most factored form it's going to be. So even though 35 can be factored into 5 and 7, We have negative 35, which can't be factored into numbers that will add to 12. So it is, in fact, prime, or another way of saying that, you can't factor it. Let's look at example 5 then. We need to factor out this trinomial. Again, it's in ax squared plus bx plus c form. Our a, the number out in front, is 1. Our b is a positive 2. And our c is a negative 63. So again, we're asking ourselves what two numbers will multiply to make negative 63 that will add to make 2. So first, let's think of some factors of 63. We can do things like 3 and 21. Those will multiply. On another one we can use would be like 9 times 7 makes 63. Now 3 and 21 are obviously not 2 apart. They're too far. So those ones won't work. 9 and 7 are only 2 apart though. So those will work. And because 63 is negative, we need one of these terms to be negative and the other one should be positive, because a negative times a positive would be negative. So we need to decide which one of these should be negative and which one should be positive so that they'll add up to a positive 2. Since this is positive, the bigger number should be our positive one. So which means 9 is positive and 7 is going to be negative. Because now positive 9 times negative 7 is negative 63. Positive 9 plus negative 7 becomes positive 2. So like before then, we'd find out our two factors, the two pieces we're breaking it down into, is x plus 9, because of our positive 9 here, and x minus 7, because of our negative 7 here. And last example, again we have our trinomial, ax squared plus bx plus c. The a out front is 1, the b here is negative 3, the c is 8. We're asking ourselves what two numbers will multiply to positive 8 that would add to negative 3. Well, if this is positive and this is negative, we would need two negative numbers being multiplied that would add up to negative 3. So the factors of 8 would be things like 1 and 8, or else 2 and 4. Those are really the only factors we've got. And if we, again, we need to make sure that they would all be negative, because they're adding to a negative number. Well, negative 1 plus negative 8 isn't going to work. And negative 2 plus negative 4, that's also not going to work. So if none of these work, again, like before, we would say this one, oops, not backwards. This one we cannot factor it. It is prime. It's so prime, it's Optimus Prime. That's going to end our 7.3 video.